This video covers chapter 17, which is all about quadratics. So if we start off with this first topic here, which is drawing quadratic graphs from their tables. Now, whenever you have a question, let's say it's on a non-calculator paper, then you'll have to fill in the table. That shouldn't be too hard. So you'll have your x values at the top and your y values at the bottom, and there'll maybe be some x values at the top. Let's say we've got like -3, -2, -1, 0, 1, something like that. And let's say our quadratic was y equals x squared plus 2x minus 3. Then what we do is we take each x value, we're going to replace that with the x's here with what's in the table, and we'll work out the value, and then we'll put it in the bottom row. So for example, if when x is -3, so y would be -3 goes in brackets squared, so working out what goes underneath that, plus 2 times by -3 minus 3. So if we work that out, we'll have 9 minus 6 minus 3, which is actually 0, so you get 0 there. For the next value in the table, you replace x with -2, so you'll have -2, so again in brackets. So notice how I put the negative number in brackets. That's important for what we're going to be doing later on. So -2 squared is 4, and then we've got -2 times by 2, which is -4 minus 3, so that gives you -3, and so on. You do the same for when y is -1, and so on, and you'd complete the table. So I put this value in. Now what's important is when you plot these points, a quadratic will either give you a graph which is U-shaped like this, yeah, it may be in a different place, but it's U-shaped, and you'll get that type of graph when the number in front of x squared is positive, so like 2x squared, or with some other stuff there, or 3x squared, but it's positive. The other type of quadratic graph you're going to get looks like the same thing but upside down, so it's going to look like this. Again, it may be in a different position, and you'll get this when it's negative, so like -x squared, or -3x squared. Anything with a negative in front of the x squared will turn the graph upside down. So that's if it's on a non-calculator paper. If it's on a calculator paper and we need to fill in the table, then we'll use the table function on our calculator. Now to get that, you press the mode button. Okay. Then we're going to find the option that says table. Now that's might be option number 3, all depends on your calculator. Then it will come up with this f of x. Okay, when that comes up, you just type in the quadratic. Type in the quadratic. Now there will be a button on your calculator that has x on it, just like a single x like that. You might need to press shift to get it, and that's what you use to get the x in the quadratic. Once you've typed in the quadratic, it's going to say start. So this is where you type in the first value in your table. So if we were doing the example down at the bottom, I'd type in -3. So start, this is the first x value in your table. Then it's going to say finish or end, and this is going to be the last x value in your table. So for example, the question that we did, that would be 1, and then it's going to say step. This is how much you want to go up in, and this is normally 1. You normally want to go up in 1s, so I'm going to say normally put 1. So it just means that when the calculator works out the table, it will go up in 1s. Now you just need to realize that when your calculator does the table, it's going to be like a downwards table rather than a sideways table. So you're going to have something like this on your calculator. So we'll have like -3, -2, -1. If they don't all fit on the screen, you might need to scroll down, and then your y values are going to be here. So for example 0, -3, and so on. So your y coordinates, your y values go in the second column. So here is your y values. So that's what we'd do if we were using a calculator. And make sure when you plot the points and you join them up and they make a smooth curve, just like one of these. So don't join them up with straight lines. And if something's out of place, so if you go around and something jumps up there, you know you've either worked out the value wrong or you've plotted it wrong. All quadratics will always be a smooth shape like this, either like this N shape or this U shape. Right, next thing we need to look at is solving quadratics. So that's this bit here. So there are different ways to solve quadratics. So we can solve them by factorizing. We can solve them by using the quadratic equation. Or we can solve them by something called completing the square. So completing the square. Okay, and completing the square is sort of going up to sort of grade 8, grade 9 when you're completing the square to solve them. Okay, so let's say I wanted to solve this quadratic equation by factorizing. So I'm going to have x squared plus 7x minus 8 equals 0. So the first thing we do is we put a times sign above the -8, a plus sign above the 7, and what I'm doing, I'm looking for two numbers that multiply to give me -8 and add to give me 7. Now those two numbers are going to be plus 8 and -1. Okay, they add to give 7, they multiply to give -8. So we do our brackets. Remember, this equals 0 because it's an equation. We put x at the beginning of both brackets because we have x here. And then we put these two numbers in, and the two numbers are plus 8 minus 1. Now to solve a quadratic, it's either that this bracket equals 0 or the second bracket equals 0. So either x plus 8 equals 0, which means that 8 equals -8, so there's one solution, or it means that x minus 1 needs to equal 0, in which case x would equal 1. So there's our second equation. Now the quadratic equation, this is when you're going to have, it's going to be on a calculator paper, and normally it will say something like, give your answer to 3 significant figures, or 2 decimal places. Yeah, whenever you get an answer that you're going to have to round, then it normally means that you're going to be using the quadratic equation. Now you need to memorize the quadratic equation, it's not given to you in the exam, and remember that in the quadratic equation you have these 3 letters A, B and C, and this is where you find A, B and C. They could be positive and negative. The quadratic equation is this: negative b, or x equals, this is how you find the values of x, plus or minus the square root b squared minus 4ac all over 2a. Yeah, so there's a couple of things. The first thing is there's a plus and a minus here. This means that it will give you 2 solutions. Yeah, and you do need to go into your calculator and change the plus to a minus or a minus to a plus. And that will give you the 2 solutions. Also, put negative numbers in brackets. So put any negative numbers in brackets, that's really important. Otherwise your calculator will get confused. And basically you just type them in, yeah, but make sure that when you type it in on your calculator it looks exactly the same as the equation. It should look any different. So for example, if I needed to solve this equation, which is y equals 4, sorry, let's change that, y equals minus 2x squared plus 4x minus 3, and I was using a quadratic equation, well, I would have a equal to negative 2, b equal to 4, c equal to negative 3. So in a quadratic equation I would have negative b, so negative whatever b is, which is 4. Now if b was a negative number, you still keep the negative sign at the front, so this negative sign is always there even if b is a negative number, so you'd have two negatives there which will become positive. Then plus or minus, so plus or minus square root b squared, so that'd be 4 squared, minus 4 times a, which is negative 2, times by c, which is negative 3. So again, can you see all these negative numbers in brackets? All divided by 2 times a, 2 times negative 2. And I type that into my calculator very carefully, first with the plus sign there, and then I'd write down the answer. Then I would scroll back and then change the plus sign to a minus sign, so that would be then the second thing that I type in, change the plus to a minus, and then get the other solution. Now completing the square is a different way of solving a quadratic equation, and in fact there are questions where it just says complete the square. So what we're going to do, we're going to do one here. So this equation we're going to solve by completing the square. So 2x squared minus 8x plus 7 equals 0. Now whenever you've got like a number at the front here and it's like 2 or 3 or 4 and it's not just x squared, you need to divide the whole quadratic by that. So we're now going to divide everything by 2 because we want x squared at the front. So whatever that number is at the front there, that's what you divide by. So now we will have x squared minus 4x plus 7 over 2, so you divide that by 2, and even 0 divided by 2 is just 0. Then we are going to put our brackets in like this. When we complete the square, this is the form it looks like, and it's always x and then half of this number here. So that half of negative 4 is negative 2, so you have x minus 2 all squared. Maybe I should have said that when you complete the square it's always in this form, x plus or minus a number squared plus q. Yeah, so that's the form we want to get it in. So we've got the bit in the brackets. Now if I were to expand that, I would get, let's write this up here, so if I were to expand x minus 2 squared, that would give me x minus 2 times by x minus 2, and that gives me x squared minus 4x, because I get minus 2x plus 4. Now can you see that that works? It makes the x squared, which is what I want, it makes the minus 4x, which is what I want, but it gives me the number 4. I actually want 7 over 2. So we take away 4, so you take away the number that this gives you, which is 4. I don't want 4, I want 7 over 2. Then the last step is just to put together the minus 4 plus 7 over 2, which will leave you with minus a half equals 0. And all we do is rearrange it to make x a subject, and then that will give us a solution. So we add half to both sides, like this. Then we square root both sides, so we'll have x minus 2 equals, now when we square root, we should show that it could be positive or negative, so plus or minus a half, And then last step, x will equal, once we add 2 to both sides, we'll have 2 plus or minus the square root of a half. So this is our other way of solving our quadratic. So we can solve by factorising, we can solve by using a quadratic equation, we can solve by completing the square. So we've actually now covered this one here, using a quadratic formula or completing a square. What we now need to look at is solving quadratics, which are a little bit more complex, where it's not just x squared by factorising, but you've got like 2x squared, 3x squared, 4x squared, something like that. So we're now going to look at solving by factorising, but factorising quadratics of the type ax squared plus bx plus c equals 0. Okay, so this is where the number, you've got a number in front of x. So it's not just x squared. It could be 2x squared, it could be 3x squared, it could be 4x squared. So what we're going to do is look at how we factorise those types of quadratics. So here's an example. Let's say we wanted to solve this quadratic. So let's say we've got 6x squared minus 7x minus 3 equals 0. So this method, first of all, requires you to multiply the first number and the last number. So we're going to do 6 times by negative 3, which gives me negative 18. So you start by multiplying the first number and the last number, whatever they are. That gives me negative 18. So now what I'm looking for are two numbers that multiply, whoops, I need to put negative 18 here. Two numbers that multiply to give me negative 18 and add to give me the number in the middle here. Two numbers that add to give me negative 7. Yeah, so multiply the first number, that gives you a new number. Find two numbers that multiply to give you that, in this case negative 18, and add to give you this number in the middle, negative 7. So this is the hardest part, trying to work out what these two numbers are. Now I know that 2 and 9 multiply to make 18, and I could probably use 2 and 9 to make 7. So I think if I do negative 9 and plus 2, that will work. Yeah, they multiply to give me negative 18 and add to give me negative 7. The next step is I now going to write down, do my two brackets just like I did before. Now remember last time when it was just x squared, I put x at the beginning of both brackets. This time I put 6x at the beginning of both brackets because it says 6x here. Then I put the two numbers in, minus 9 plus 2. We're not quite finished. The last step is to see if you can cancel down either of the brackets. In other words, look at the two numbers in the brackets. Can you divide them both by the same thing? I can here. I can divide both of those by 3. It has to be the biggest number. And these I can divide by 2. Now sometimes you can only cancel down or simplify one bracket. Sometimes you can't simplify any of the brackets. In this case, I'm able to simplify both. So now I divide both of the numbers by 3 in the first bracket because I'm able to do that. So I get 2x minus 3. Then in the second bracket, I divide them by 2 and I get 3x plus 1. Okay, that is now factorised. Now when we did the question before, let's write this here, 2x minus 3. What we did was we said, right, what makes the first bracket equal to 0 or what makes the second bracket equal to 0? So we'll do the same thing again. So I want either the first bracket equal to 0 or I want the second bracket equal to 0 to find the solutions. Right, so the first one, if I add 3 to both sides, I get 2x equals 3. Divide both sides by 2, I get x equals 3 over 2. So that's one solution there. So we'll do the same over the other side, solve that equation. So we'll take away 1 from both sides, then divide both sides by 3. We can leave it as a fraction, so then we get negative a third. Okay, so that's our other solution. So with this method, you multiply the first and last number, you find a number that multiplies to give you that new number you've just created and adds to give you the middle number. You put that number in the brackets along with whatever's at the front of the quadratic. In this case it was 6x. Then you see if you can cancel down. Okay, that was our cancelling down step here, or simplifying step. Now, as I said, you can't always cancel down. Sometimes it's only one bracket that can cancel down. In this case it was both. Then once you've got that quadratic, you then see what makes either the first bracket equal to 0 or the second bracket equal to 0. Okay, you need to be able to find significant points on a quadratic graph, and the significant points on a quadratic graph are these. So this is the x and y axis. Let's just do a quadratic. So we need to be able to find the coordinate of the minimum point. That's a significant point. So what's the coordinate of the lowest point down there? We need to be able to find the coordinates where it crosses the x-axis, and basically where it crosses the x-axis, that's what we call the roots. And how do we find the roots? We find the roots by solving a quadratic. So they're the solutions. When we've been solving quadratic, those solutions that we've been working out, like x equals 2, x equals 3, those types of things, that's where it crosses the x-axis. We may need to find where a graph crosses the y-axis, so let's just draw one that goes the other way up. Okay, so we might be asked to find this point here where it crosses the y-axis. What's special about that is that x equals 0, so you just substitute x equals 0 into your quadratic to work out what y is. And if it's this way up, like this, we'll want to find that point, which is the maximum. So the maximum is this highest point. Yeah. Now we can find a minimum and a maximum point. We can do that by completing the square. That will help you find the minimum and maximum point. So here's an example. So let's say I completed the square and I ended up with something like this: x minus 3 squared plus 2 equals 0. Okay, so that in this case it would be the minimum point, and the minimum is basically the smallest this can be. Smallest this can be. So I've completed the square and I'm looking at that and I'm saying, right, what's the smallest that this can be? Well, the smallest that this can ever be is 2. Yeah, the smallest it can be is 2. That's because I can make this bracket equal to 0. I can't get rid of the 2, but I can make this equal to 2 when x is 3. When if I put 3 there, this bracket becomes 0 and I get 2. So that basically means the smallest it can be is 2 when x equals 3. Now the smallest it can be is basically y, what y is. So the coordinate of the minimum point would be 3, 2. So you basically find the smallest it can be and the value of x that's going to give it the smallest. So that value there of 3, 2 would be the minimum point. So completing the square helps you do that. Right, we need to be able to also solve simultaneously. Now hopefully you'll remember we can solve simultaneously either by looking at where the graphs cross or by solving algebraically. Okay, so if I had a quadratic graph like this and I had a straight line graph that looks like this, these points where they cross, that's the solutions. Okay, so these 2 points here, solutions to solving the equations of the graph equations of the graph simultaneously. Yeah, so if the graphs are there, or you can plot them, if that's what it asks you to do. Whoops, that simultaneously doesn't look very good. Simultaneously. Yeah, if the graphs are there, or you've been asked to plot them, find out where they cross, and that will be solving them simultaneously. We may need to do it algebraically. So let's do an example where we're going to solve a quadratic and what we call a linear simultaneously. So we're going to do the same type of question, but we are going to do this using algebra. Right, so we're going to solve this. We're going to have x plus 2y equals 3, and we're going to solve simultaneously with x squared plus 3xy equals 10. Now we don't solve these in the same way that we solve two linear equations where you do same sign, subtract and that. What we need to do is we're going to rearrange the first equation and either make x or y the subject. I'm going to make x the subject because that's easier by taking away 2y from both sides, and then I'm going to take this and I'm going to substitute it into this equation. So everywhere I see x, I'm now going to put 3 minus 2y. So that will give me 3 minus 2y squared. So I'll replace the x with that and it becomes all of that squared, and then plus 3x, so that's going to be 3 times 3 minus 2y times by y, so that's like 3xy equals 10. I'm going to multiply all of that out, so I'm going to expand the brackets and simplify it. Now I haven't got a great deal of space, so I'm going to try and shorten this down. So when I expand the first bracket, I'm going to end up with 9, so it's going to be like 3 times 3. Let me just put up here what I'm doing. So this is basically what I get from doing 3 minus 2y times by 3 minus 2y, because you're squaring, you're timesing it by itself. So it's going to be 9, and then I'm going to get minus 6y, then minus another 6y, and then I'm going to get plus 4y squared. So let's expand those brackets, then expand the second bracket, which is going to be multiplying those out, and then I've got to multiply that by y. So that's going to be 9 minus 6y, okay, and that's going to get times by y again in a minute, equals 10. So what I've got now is 9 minus 12y, that's the minus 6y, plus 4y squared. Then expanding the second bracket, so I've got plus 9y minus 6y squared, and then I'm going to bring the 10 across like that. I want it to look like a quadratic, so simplifying that, I will have negative 2y squared, okay, so that's that and that put together. Then I've got minus 12y plus 9y, which is going to give me negative 3y, and then I've got 9 there, take away 10, so it's going to be minus 1 equals 0. Now I'm not going to completely finish this off. Now what you would do, you would use any method you want to solve this quadratic. Solve quadratic. That will give you two values of y. So you could use the quadratic equation or factorizing. Then when you've got those values of y, you put them into this to get your values of x. So what you will have is a pair of values of x and y. So you'll have two values like this, and make sure you pair them correctly. Whatever y generated the x, they need to go together as a pair. And what you've got is what we did before graphically. You found the coordinates where they cross. Okay, so get the linear one, make x or y the subject, substitute it into the quadratic one. Expand the brackets carefully and simplify. Then you'll end up with a quadratic like this, which you need to solve using the quadratic equation or by factorizing. Normally factorizing is going to be the quicker one. Find your values of y or x, Then substitute those into the linear equation that you started with to find the other value of x or y, and then make sure that you keep those pairs together for your answers. Now the last thing we need to do is right at the top end is solving quadratic inequalities. So these are things like, let's say you've got x squared plus 5x plus 6 is less than 0, so it's not equal to. Now we start off by solving this in exactly the same way as you would if it was equal. So find two numbers that multiply to give 6 and add to give 5. So those three numbers are 3 and 2. So I'd have x plus 3, x plus 2. I'd find the solutions from there. So x plus 3 equals 0, means that x is negative 3. I'll do the same here. X plus 2 equals 0. That means x is negative 2. Now at this point I would sketch the quadratic. Now because the number in front of x squared is a positive 1, it's going to be u-shaped, and it's going to be a u-shaped quadratic that crosses the x-axis at negative 2 and negative 3. So I'll just sketch here negative 2, doesn't have to be to scale, negative 3. Then I'm sketching my quadratic. It's going to be u-shaped, crossing at those points. Remember, those solutions are the roots. Now below the axis is less than 0. On the axis is equal to 0. Above the axis is greater than 0. Now because this equation here says solve it for less than 0, this is the bit of the graph that I want. Now when is this graph less than 0? When the x value is less than negative 2 and greater than negative 3. It's between those points. Now if instead our equation was x squared plus 5x plus 6 was, let's say, greater than or equal to 0. Now when is this graph greater than or equal to 0? Well, it's greater than or equal to 0 at these points here, the ones that I'm just shading in green. And what are values of x is that? Well, that's when x is greater than or equal to 2 and when x is less than or equal to negative 3. Sorry, that should be negative 2 there and negative 3 here. So start by solving them the same way as a normal quadratic. Find those solutions, those roots where it crosses the axis. Draw a sketch and decide if you want the bit above the axis or the bit below the axis.